My name is Mohammad Ali Kashfi. I'm PhD student at Lahore University. My background is traffic flow theory and AI. The main idea of our manifesto is from flatland to full spectrum, liberating transportation research across three dimensions. That is dimensions, geographies, and behavior. And we know that for the past 50 years, transportation mostly focused on land transportation and forgot about the future. Imagine future that transportation will move to third dimension, that is aerial vehicles and aerial autonomous vehicles. This research needs quite focus. And the second is regarding geographies. It means that most of the research today are conducted in the global north, and data collection are in the global north, and also theories developed in the global north. However, much of the other countries in the global south are forgotten, and theories are not there much discussed. And the third dimension is from behavior perspective, that is human factors. And this dimension relates to how the future of autonomous vehicles and also aerial vehicles will impact the human behavior and how human behavior will change and adapt those systems. Accordingly, our future research horizon thinks about liberating these dimensions. First dimension liberation, it means that the research in the next 50 years should focus on a third dimension of aerial mobilities. We believe that this volumetric phase completely differs from the land phase or flat land phase. The new models should be developed there, the interactions should be there, and also new definitions and research should be established for that purpose. From geographic perspective, the models, the research, and also data collection should be conducted in the global south. It should not be the case that models developed in the global north and assume that those will work on the global south. The complexities in the global south is substantial. The interactions, the dynamics, and also the heterogeneities that exist in the geographies will be completely different in the global south. So for this purpose, the research should be conducted in the global south, the models should be developed there, and also data collection should be conducted there. So we should have new research completely from that perspective. The third dimension is behavior. The mixed autonomy and also the full autonomy, the behavior, how change between human and also this algorithms of AI should be the focus of the research that is not much considered in the past 50 years. For this purpose, we divide the future research into three phases. Foundations that starts from 2026 up to 2036, and integration, that is integration of autonomous vehicles, aerial mobilities with the current human controlled vehicles. And the third phase is that is from 2051 to 2076. This is full spectrum. We expect that in this phase, volumetric flow is high, and also much of the market is autonomous vehicles. So the research in this case is discussed accordingly in three phases. We want to comment that the future research, any model development should answer the questions. And how many dimensions that this operate? And whose behavior does it encode? Whose geography generated its theories? What watershed it ignores? Whose access does it measure, and whose does it render invisible? Research that cannot answer these questions is research the next 50 years cannot perform.
My name is Ankareza Ankunda. I'm currently a PhD student at Lahore University, focusing on human factors in transport. Like every technology, transport has also been transformed recently in the recent years. However, the success of that transformation, which has majorly been by technology, is highly dependent on the human uptake, how the humans adopt the behavior. So we predict that by the year 2076, we are going to see a shift in two perspectives. For example, we are going to move from 2D to 3D spatial utilization. We already started seeing some pilot projects on drone delivery services where you are having drones delivering items from place to place. You are going to have flying robot taxis, So by 50 years from now, the human behavior is going to not only deal with the 2D space, but also the 3D space utilization. Another thing, we're having the autonomous vehicle technology that has recently become popular, but the challenge right now is that it is not yet mainstream. 50 years from now, autonomous vehicles are going to be the mainstream. Now, we are going to have things such as skill depreciation, where the humans no longer need to know how to drive. The human level of trust in the system is going to be high, because now the autonomous vehicles are able to perform to the maximum levels. However, what happens in cases where there's a system failure? How does the human react to that? So we really need to study this human behavior. Then another issue that we have is the movement from the Western world to the global south. In the Western world, the roads are homogeneous, meaning the drivers follow lane discipline. Different vehicles have different lanes. So human behavior in such an environment, when you compare a person crossing a road in such an environment to someone in the global south, such as someone in India, in Uganda, in Bangladesh, they are two different challenges. In those global south countries, traffic is heterogeneous, disorganized, drivers don't follow lane discipline. So a human is more stressed when they are crossing the road. So future research shouldn't just bring models from the Western world and just impact them on the global south, but rather use the global south and in the context of how the humans behave in that sector. Thank you.
Hello everyone, I'm Jin Xiaowu from Lapo University. For decades, transport system has been designed as if they exist in isolation, as simple networks of road and flows. But the real world does not work this way. Transport systems are part of the environment. They interact with rivers and climate. And under extreme conditions, these ideas of separation break down completely. Nature hazards show us this very clearly. Floods, landslides, and debris flows were not just external events. They are physical processes that evolve over time and space. When they interact with infrastructure, the system does not simply fail, it changes. Roads can turn into water channels, bridges can collapse, and entire networks can stop functioning. This is not just about theory, it is already happening around the world. In the Pakistan flood of 2022, a large part of the country was underwater, and many roads were destroyed. But roads were not only damaged, they also changed how water moved, so making the flood severe. And in Southeast Asia, recent flood has covered urban roads, forcing transport systems to operate under changing conditions. Across all these events, we see the same pattern. Hazards involve, infrastructure reacts, mobility is disrupted, and people adapt. This is not a single event, it is a continuous process. During flood, water depth and speed directly affect road and vehicles. And roads go underwater, accessibility drops, and routing decisions depend on real physical conditions, not just maps or networks. Look ahead the next 50 years, this challenge will only grow. Climate change is increasing the frequency and intensity of extreme events. Flood will become more severe. Landscapes will become more unstable, and transport systems will face constant environment pressure. So we need to rethink transport. It is no longer just a network problem. It is a dynamic system that is closely linked with the environment. We need to move from separation to connection, from static models to dynamic systems, and from simple assumptions to a more complex understanding. Because in the next 50 years, transport will not just operate within the environment. It will have to adapt to a changing and uncertain climate system.